Welcome, everyone. Thank you for coming. Mary, thank you for the introduction and such. I work on a space telescope, small one, but wiring, and I still can't believe that thing is going to be up there the better part of 70 years because it's great. It's kind of like a taxi. You use it and you leave it, and when you get another fare, you start it up again. Same thing. This is going to be kind of fun. Tonight, however, we're going to be talking about what's coming this year for everyone, the highlights of the night sky for 2026. So there's a lot of stuff happening, and we're going to be starting that right now. Okay, a new year beckons, calling us to look to the sky for inspiration and knowledge. So first, if you're going to be doing any kind of flight at all, I don't care if it's in the atmosphere of the Earth or if you're going to be flying between planets or stars, you got to get your bearings. So, first things first. Oh,
Well, it's just to get it out of the way.
that's actually that's very good. Thank you. Okay. Before we get going over here, you'll be hearing me talk about degrees and angles and such as I go through here. Don't worry, there's no test in trigonometry at the end of the day. However, you should be aware that if you want to observe the night sky, there are a number of guideposts that you can learn. And of course, one of the big ones over here is the Big Dipper. How many people have seen the Big Dipper in the sky? I'm just curious. Okay, and pretty much everybody. Okay. Well, here's a little bit of background. If you look at the actual ball of the Dipper, the height of it is about 5.5 degrees. It's 11 full moons in diameter. From the top pointer to the back of the ball is 10 degrees. Between this front star in the ball to the first star in the handle is 15, and of course the whole constellation from bottom to top, if you will, is 25 degrees. Your hand, you have a very accurate hand. It's an amazing thing. Most people don't realize it, that because of the eye's optics, we can all look at the same area here between the thumb and the pinky. And no matter who you are, where you are, you have a 22-degree angle as you hold it out in front. If you make a fist with the thumb on top, it's 10 degrees across. And you just look at the first four knuckles, and that's 7 degrees. So you are a walking calculator. You can determine the distance between stars and other signposts in the sky. Okay, so let's start off the year right. Spring begins in the seasons, March 20th, 9:45 a.m. Eastern Standard Time. And for the first time in a long time, folks, I can talk about the summer not having daylight savings or daylight wasting, they should put it. It's all standard time finally this year. I grew up with this stuff. I hated it. My mother would put me to bed at 6 o'clock, and the sun's still up in the summer. That's a real bummer, you know. Okay. Speaking of summer, begins this year June 21st at about 3:25 a.m. Fall begins September 23rd at 12:06 a.m. And winter begins again December 21st at 3:49 p.m. Eastern Standard. Okay. And here's the reasons for the seasons. Our Earth has an angle to its, as it goes around the orbit, of about 23.5 degrees. And because also in a lesser amount, the Sun-Earth distance varies as the year goes on, as you might expect, what we call perihelion, closest approach, or aphelion, which is the furthest away. Now, interestingly enough, the summer solstice in the northern hemisphere, of course, varies June 21st, 22nd, but it's where the Earth's tilt is tilted, the northern hemisphere is tilted more to the sun. In the winter solstice, it's tilting away. That's why it's so cold, because the angle of attack, if you will, of the light is much sharper. And then autumnal and vernal equinoxes, they basically the Earth is facing almost square on to the sun. The reason for the seasons. Now, if we had a straight up and down, we would not have a circular orbit. Circular orbits don't work. You'll have them for a little while, but there are certain little perturbations that occur between a given star and its planet, which will make it into an elliptical orbit. We have an elliptical orbit right now. It's been doing very nicely, thank you, for the last 4 billion years. Okay. Now, you can use okay, first things first. How many people here have seen the Big Dipper? Okay, bunch of people. Hey, terrific. This is what the Big Dipper can do for you. If you're looking in the winter sky and you're looking for objects, you can draw a line from the back of the bowl to the bottom of the bowl and extend it out. And the first bright pair of stars is Castor and Pollux of the constellation Gemini. Right next door to it, you just follow the top of the bowl up. And this is a long distance, so each of these is about 8 handfuls, if you will. But you find a bright star called Capella, very much like our own sun, with one big difference. It's about 20 times as big. It's nice and bright. In the fall sky, usually the bowl will differ the pointer stars to Polaris. But if you continue that, you'll hit a big square of stars over here. This is called Pegasus. And above that is Andromeda. Some people already are probably ahead of me a little bit, following the middle star in the Big Dipper handle through Polaris up to a W in the sky of stars. It's called Cassiopeia. So you can use this to find other objects. In the summer sky, it's kind of fun. About those back stars of the bowl of the Big Dipper, follow through and find the first bright star you hit is Deneb. Actually, the tail feathers, if you will, of Cygnus the Swan. If you follow this and kind of like lazy arc over next to Deneb, there's another bright star called Vega. And if you follow the line from the bottom of the bowl to the rear of the bowl, and then 2 more stars and the 3 in the handle, all the way down, you have this rather faint constellation. You can't see it too easily here. But if you get into the country, you'll be able to see this is Hercules. And in this trapezoid here, right about here, a pair of binoculars to show you a little fuzzy patch. The telescope will show you on the order of about 500,000 stars, all bunched together in a globular cluster called M13. It's a cool object to see. You can actually see it even with binoculars here in the city. And oh yes, can't forget the spring side, go the opposite direction. You find Regulus in Leo. And if you follow that curve all the way through, you arc to Arcturus, and then from there you speed to Spica. So you can also view the spring sky. All these are bright signposts. I recommend strongly, though, getting away from the city. Because of all the stars that you're seeing over here, all right, I've been in this business since I was about, I'd say about 8 years old. I'm a good number of years beyond that. And I have watched a lot of these stars starting to fade out because of our light pollution. It's terrible. Energy costs have been going up and up and up, as everybody knows. But they keep on putting up lights. Yeah, they're more efficient nowadays, but more importantly, they're much brighter and they're colder, a little more shifted to the blue, which is why when you're driving down the highway, this imbecile coming the opposite direction has these ordinary, not high beams, these ordinary beams which are blue. That's a halogen, or the new LEDs, which are replacing a lot of bulbs. They're very, very good. They last a long time, and they can take your night vision away in a moment. It's crazy. But get away from the city. You know, even, well, I grew up in the shadows cast by New York City in Gothenburg and now North Bergen, New Jersey, right across the river. You're lucky out here, at least you still have something related to a sort of kind of dark sky that's clear. So you should be able to see almost everything you're seeing on here in the constellations. And if you don't, you can come down here in a clear night. We have laser pointers, speaking of lasers. Laser pointers allow us to point out objects to you. Okay. So right now, we, of course, have the winter sky. If you get away from, really pretty much from city lights, but you can still do this. You will see Orion the Hunter, Betelgeuse, Bellatrix, Rigel, and Safe, which unfortunately is not included in the names here. But you can't miss this set, especially with the 3 stars across of his belt. And using those 3 stars to knock it down, come to the brightest star in the nighttime sky in either hemisphere, Sirius. You can't miss it. Follow, of course, this way, straight across the top of of Orion, and you hit another little star called Procyon, Alpha Canis Minoris, of the little dog for its brightest star. Come up from that right angles, and you hit Gemini, Castor, and Pallas. And up here, actually, this is one of my favorite areas. Go straight up from the far left star in the belt of Orion to the top here, straight all the way up to Capella. There are a number of little clusters of stars all scattered through here. You can actually see them in binoculars. Telescope works better. And of course, Aldebaran, we follow from the leftmost star in the belt of Orion to Bellatrix, all the way up to Aldebaran, and continue it, and you have a nice star cluster called the Pleiades. You got even a small pair of binoculars should knock your socks off. They're called the Seven Sisters. I count only eight, probably six naked eye, but only a small pair of binoculars, 7x35s, will show you a beautiful little cluster right through here. In the spring sky, moving right along, as they say, using the Big Dipper, the rearmost stars of the bowl of the Dipper follow all the way down to Leo and to the star Regulus and Ogiva. But Regulus is the brightest one, the heart of the lion, if you will. Denebula is the tail of the lion, the back here. But it's important because if you look at these stars here, the triangle of stars, and follow these down, you get Spica, constellation Virgo. As a matter of fact, there's another way of doing this. You look up to the Big Dipper. Big Dipper is like the guide to everything, at least in the Northern Hemisphere. And you follow the arc of the stars to an orange star called Arcturus. Arc to Arcturus, and from there, you almost straight down speed to a blue-white giant called Spica, Virgo. So you see, you use the Big Dipper and you're able to find all sorts of objects and stars. In the summer, probably in the Northern Hemisphere, this is probably the most beautiful time because you have a lot of bright stars. You also have the Milky Way stretching across the sky. Deneb is one of the brightest ones here. Deneb and Vega and Lyra. And then Altair. These are all easy to see, even in the city. This is called Summer Triangle. You can follow Vega through the center star and Cygnus, swan here, all the way over to the great square Pegasus, where we're going to be stopping later with the fall sky. It's quite a beautiful thing here to go the opposite direction, and you hit the keystone in Hercules, right about where the K is here. If you got a good pair of binoculars, 10x50s or larger, a little more magnification, and a tripod, you'll see a little baby fuzzy right about here. That is M13. It is a globular cluster, a ball of about 500,000 to 1 million, depending on who you read. That cluster of stars formed together, and we think in the early universe, there were many, many millions of those globular clusters, and they coalesced together to form galaxies like what we're in right now in the Milky Way. From down to Vega, you have Altair. Now, how many people have seen an old movie, but a great one, called Forbidden Planet? A couple people, okay. Altair, this is Altair. Fourth planet ain't there no more because it got blown up. Actually, it's in the future. I think it's supposed to be around 24th century. So we can still see the planet. But there's Altair. It's a real star. Very bright, beautiful object, too, a white star. And if you follow, go through Deneb, the center star of the Northern Cross here, Satyr, through Alberium. This is beautiful. It's called the Cub Scout star. It's orange, gold, and blue. Beautiful contrast. Come back in the summer, we'll show it to you. It's worth it. Take a good look. Keep on going all the way down. The Sabic and Ophiuchus, the snake antler. This guy took care of all the snakes and such for us. But in this area, if you keep going, you'll be finding also in the summer sky Antares, which is a supergiant in the Scorpion, the heart of the Scorpion, Scorpius. Okay. And then finally, In the autumn sky, you have the great square Pegasus. You can't miss this. So these are nice bright stars forming in. You follow them up to Cassiopeia. It looks like an enlisted season of the autumn, fall. It almost looks like an upside down W. Follow it the other way, and you go to the Ditva and see this sea monster. Whale. I don't think whales are monsters, but I didn't name them. You follow from Alpheratz through Andromeda. Yes, that Andromeda as the galaxy, which is right about here. You're able to find Murphak and Perseus down to the Pleiades. This is one of the prettiest star clusters you're ever going to see. Pair of binoculars, as a matter of fact, you've got good eyes. You might even be able to resolve the six brightest stars. It's supposed to be called the Seven Sisters. It's actually that's the mythology. There's only six stars there, but a lot of little faint ones around. Okay, and I'm going to give everybody an observer alert. I don't have a siren in here. Comet C 2025 R3 Pan-STARRS is the project that discovered it, the telescope and equipment, discovered on September 8th of last year. Should be bright enough in the morning sky, write it down, between April 12th and 15th, roughly 15 degrees. Remember I told you about holding your fist out? And it's 10 degrees. So it's like a fist and a half above, just about local sunrise. Closest to Earth on April 20th of this year. You got to get away from the city lights and find any clear eastern horizon. Yes, it's going to be a trip. You're going to have to go. But if everything works out right with this is about a second magnitude comet, which is, if you're in a dark sky, it's going to be impressive. So we'll keep our fingers crossed on that. And if we get any photos, we'll probably have them posted up here or on the website. Okay, moon matters. We have 3 supermoons. It's only a supermoon. In 2026 meaning that the full moon will be especially bright in the night sky thanks to its closest to Earth on January 3rd, we missed it, November 24th and December 23rd of this year. The moon's going to be in total eclipse, in other words, in the dark, what's called the umbra shadow of the Earth, on the morning of March 3rd, low in the western sky. However, it's going to set, just gets into totality phase, completely inside the shadow of the Earth. And it has the nerve to set about 6 minutes later. So you're going to have to get a good western sky horizon. On August 28th, the moon will be in a partial eclipse just after local midnight. Maybe you'll see this better, but if we're lucky, maybe sometimes with partial eclipses of the moon, some of the red light that all the sunsets and sunrises on Earth shine through our Earth's atmosphere and get projected on the moon. So you might have an interesting appearance to that. So as I say, mark it on your calendar, folks. Okay, and more about the moon. I mentioned before it's called a supermoon. Well, on the one on December 23rd is especially bright, it's going to be only 228,000 miles away from the Earth. That's actually pretty darn close. The normal distance is about 239. It may not sound like much, but it's enough to increase the brightness. And this is what it's going to look like. This is the constellation Taurus, bright star Aldebaran. Over here is Gemini. And over here is going to be the moon. Yeah, it's going to be bright and will beyond cast shadows. It may be sharp enough light, so you put your hand up like this to see a very sharply defined edge, whatever it's projected onto. Great for moon viewing, more or less, but lousy if you're trying to photograph the night sky. Oh well. Okay, I think I mentioned, we have a lunar eclipse coming up on the March 3rd of this year. From the New York City area, it starts at I'm sorry, folks. It's going to start at 3:44 a.m., be about 30 degrees up, which puts it about 2 hands high in the western sky. It hits the umbra, the dark shadow of our Earth, at about 4:50 a.m. at 17 degrees altitude. Totality has the nerve to start this late, or early in the morning, at 6:04 a.m., 3 degrees up, and it sets at 6:28. I'll tell you, that's very inconsiderate. However, it's kind of cool to watch that. I've watched the moon in eclipse and setting in November. I think it was November of 2024. It was very cool and freezing, but it was great for me, at least because where I live, I'm right on Route 1 and 9, Tunley Avenue, up in North Bergen, and I was just on the porch, and I could see it as it's going past foreground objects. I'm saying that's fantastic, and it was a brick red, absolutely beautiful. This will be too. Okay. Now, to give an idea, everybody's probably familiar with this. Moon phases. When you have new moon, we can't see it usually because the sun is getting in the way. Sometimes the moon gets in the way of the sun, and we have what's called a total eclipse. Waxing crescent, first quarter roughly is about 8 days later from new phase. Full is about 14 days, and you can see it's fully illuminated until the Earth gets in the way. That's where we got that total eclipse of the moon. Not quite a week later, waning gibbous, meaning that it's starting to go into shadow. Bless you. Third quarter, as the name implies, it's the other side of the moon, as opposed to the first quarter. A waning crescent, and of course, unless you have a total eclipse of the sun, you're not going to see the new moon. Okay. What's really happening, I mean, it's a nice diagram, but what's happening is that the Earth and the moon are locked together in a dance. So new moon you usually can't see. Waxing crescent, first quarter, waxing gibbous phase, full moon, and back the other way. And once again, back over and over, literally for millions of years. Okay. For those that are interested in looking at objects here, one of these days we have to put these onto the website so people are able to utilize them. But there are a lot of features to see, which is a good reason for you to come back here. Hopefully on a Friday close to, say, this time, moon being 5 days old, because there's quite a bit of detail here. Tranquility Bay is right over here, Mare Tranquillitatis. And, there were first human footprints up here. They have various craters and such that are named Hercules, and not to be outdone, Atlas, a little bit bigger. That's how they name them. And Rufus Altai, which itself is a crack in the surface of the moon. It's really cool. At 8 days old, you can see there's a lot of detail came out. I point your attention to Plato, which is about 55, I believe, miles in diameter. But the full bottom is almost, from a geologic point of view, is almost flat and very dark. Copernicus, named for the astronomer. One of the largest ones here is 60 miles across. Has anyone ever driven from New York City to Trenton? Couple people? Well, that means on the moon you have equivalent of driven across Copernicus. Believe me, the road is lousy up there. Alphonsus, where we believe that there was some volcanism as recently as, I believe, 1920. See little red dots occasionally there. And they're even, those that are close in, you can see they're just little blackened areas. And telescope is very impressive. That's Alphonsus. Maybe there's activity there, we don't know. I get landed there. They almost did land one of the Ranger series for photographic vehicles and changed their mind at the last minute. Tycho, which is about not quite 20 miles across, and it has this beautiful race system. Just about make out, there we go. Just about make out some of them in this picture. And then Clavius, which is about as big as New Jersey, but it also has small craterlets in it that you can see with the telescope. Okay, 10 days old, shadows moving across. There's a better shot of Copernicus crater over here. There's Plato with its dark lava flows on it that make it that dark. There are a number of other objects through here. One of these days, man, I'm going to have to make a couple of these in black and white and just have them available for handouts. So I think that's what we're going to do with this too. So come back in about 2 weeks if you don't mind. And we should have them over for free at the front desk. But there are a lot of objects through here. Humans first landed on the moon right about here. We want to follow it, Serenitatis, through here, and you can see, go carefully enough, it's just a little bit darker around the edge than in the center. That's because there are two lava flows here. We know that because we did get samples from it. I believe it was Apollo 14. And there are other objects through here. Lots of craters. Copernicus especially, because it has a, as you can see, it has a ray system. Whatever created this, probably, I don't know, maybe the dinosaurs saw it being formed roughly 120 million years ago. Must have been spectacular. But well, they didn't have telescopes so either. But this is remaining, it's about 62 miles across and very, very well worth looking for. And the telescopes here, it's very impressive. Okay, and at 13 days, almost full moon. We have Plato, which is that dark bottom crater and such through here. There's a mountain in the middle of Mare Imbrium, Sea of Clouds, right here called Mount Montes Piton. Archimedes crater through here, that Archimedes. And this one over there, Aristarchus, is one of my favorite areas here, because this is actually, you can't see it here, but in the telescope, you can see it's actually standing about 5 miles above the surrounding mare, or sea, if you will. And this is a very recent crater, maybe as little as 20 million years old. 20 million years old on the moon is like it happened yesterday. And there are other many good features. Like I said, we got to put that together so people can go to their own telescopes, or even come here and look through ours when we have it, so you can see, hey, I saw this. There you are. Okay, now I didn't demarcate this because, quite frankly, it'd be too complex. But a 20-day-old moon, as the moon literally is losing the sun, shadows are getting longer. There's Copernicus crater again. There's Archimedes crater, Plato up here, and 3 craters in particular. This one here, Alphonsus, where William Herschel, noted astronomer, discovered Uranus in the 18th century. And a number of people have seen where these 3 dark spots are over here, glows every so often. I've yet to hear of it in current time, but it's definitely some type of volcanic activity. And oh yeah, you got to get up early to see this darn thing, but it's worth it. Okay, now everybody's probably saying, wow, what happened with the meteor showers we've heard about? Well, here they are. The best dates for seeing shooting stars, April 22nd to the 23rd for the Lyrids, which will be in, again, most of these should be seen in the early morning, I'm sorry, 2 a.m. But you look to the east, roughly about a spread hand or two up, and wait. If it's dark enough, you start seeing some of the meteors come through. August 12th to the 13th for the Perseus, this is going to be a great year because it's the dark of the moon, which means you will see even the fainter meteors come through. And if you get away from the city lights, it's going to be like a celestial firework. November 17th to the 18th for the Leonid, which is nice. And December 13th to the 14th for the Geminids. The Geminid shower is one of the most reliable ones. It was so doggone cold, it'd be probably the most popular. Okay, so you have to observe after midnight. I'm sorry, you're going to have to get up like me. Okay, in a dark area, away from everything. Use a red light flashlight when you're going to be walking around in this hopefully a protected park someplace. And watch about halfway up in the east and basically wait. And they will come in after about, I'm guessing after about 1 a.m., no matter what meteor shower it is. I think there's only one that actually comes has the decency to come in the evening, but it's a relatively small one. Okay, those of you who are science fiction fans may recognize the top. Planet Patrol was a cartoon, well, actually a puppet show, which originated in the early 1960s in Britain. But they had very imaginative plots for something that only lasted a year. So I had to borrow it. Heck, I stole it. We're going to talk about the planets in 2026. Just some planetary terms. A superior planet is one that orbits the sun outside the orbit of Earth. Inferior, poor thing, within the orbit of the Earth. The Western and Eastern quadrature is a holdover really from astrology. Sorry, I had to use the word, but they did give us at least some ideas of planetary motion. So I'll give them a little bit of credit. If you have a superior planet, of course we're superior, but if it's a superior planet, Earth, outside the orbit of the Earth, it comes to what's called opposition. And I'm going to get a little ahead of myself here. Jupiter is coming to opposition tomorrow night. Now that means it's on a straight line from the sun to the Earth, lit up completely, very bright, and it gives more detail to. Usually, it's a little bit closer to the Earth as well. We're going to be looking at inferior conjunction and greatest eastern and western when we look at an inferior or interior planet. So let's move along here. Okay, Jupiter. It's up there right now. Can't see it thanks to the clouds stuck on it. Okay, the largest planet in our solar system hits opposition on the night of January 10th, see, tomorrow. And it's easily seen in any quality telescope. Now understand something here. That's the time when it's in line with the Earth relative to the sun. It doesn't mean it's going to disappear until next year. We're gonna have like about 3 or 4 months after this to be able to see it with our telescopes. We'll be able to show you some of its moons. The four largest moons out of 95. Yeah, small little chunks of rock here and there, but those four are the largest. It can be watched with just binoculars on a tripod, or if you're really good and able to hold them steady, you'll be able to watch them as they move night by night around the planet. And oh yeah, I'll point out one more thing here. With a small telescope, this guy over here has been noted for I'd say the better part of 200 years. This is the Great Red Spot. It is a hurricane with the surface area of that of the Earth. It is huge, and it fades in and out every so often. Many of these little ones over here are only about the size. But this is the one to watch for, the red spot. This is a hurricane beyond name. It's unbelievable stuff. And you usually see the cloud decks here. The dark material is coming at you and starting to fall back. The white material starts replenishing it. So we know the weather on Jupiter is completely different from what we have here. Planet Mercury can be seen like a star-like object on February 19th, just after sunset in the west. And it's a fast mover. Remember, it's the closest to the sun, 88-day orbit. On April 3rd in the east, 27.8 degrees ahead of the rising sun. And the best easy viewing, I like to get my sleep too, sorry. In 2026 is on June 15th, about roughly 25 degrees following the setting sun. So you get out there, you get set up and take it easy. It's June, maybe get a nice cool drink and such. And you wait for it to get a little bit darker in the west, and the first bright star you see, that's going to be Mercury. Most people have never seen the planet. It took me until I was in my late teens to be able to see it. Okay, August 2nd, 19 degrees ahead of the rising sun. The 12th of October, 19.6 degrees in the west. November 20th, again in the eastern morning sky, 19.6 degrees. Okay, Venus, you can't miss this puppy. It will be best seen on August 15th. It will be at what's called greatest eastern elongation, almost 46 degrees from and following the sun in the west. So 30 minutes after sunset, maybe even before then, so you can scan with a pair of even small binoculars, little bright point of light, that's Venus. And there'll be other good viewing opportunities during this year here, but it's the best of the bunch. Neptune, which is the second planet to be discovered with a telescope, and the first with the guidance of mathematics, reaches opposition, best seen from Earth, on September 25th. It's faint. I'll say it like it is. It's about 7.8 magnitude. The human eye, in good health, lots of nutrition, lots of sleep, you'll be lucky to touch maybe magnitude 6. That's an order of a factor of about 6 times fainter than the faintest star. So you need a telescope. But a telescope will probably show you the largest moon of Triton. And Saturn, this is everybody's favorite planet. We get so many requests to be able to see this planet, especially when it's not visible in the evening sky. It's amazing. But everybody likes it. It's got the big ring system. Oh yeah, before I forget, there is a planet we just looked at, Jupiter, also has a ring, but it's very, very faint. So you're not going to see it through any telescope, not even the largest one here on Earth or in orbit. You have to photograph it. In this case, it comes out and jumps at you. It'll reach opposition, that's lit up. On October 4th, fully lit by the sun as seen from Earth, and the ring system is starting to become more prominent. See, at 2 times during its orbit, here, over here, you can see, all you see is the shadow of the rings on the ball of the planet because they're edge on. They're big, they're absolutely beautiful too. 145,000 or so miles across. Spectacular. Nowhere else in the solar system do we have a world that has this type of ring system. It's all water ice, dirty ice. Comet got too close apparently a couple, 10, maybe 20 million years ago. And the gravity of Saturn ripped it apart. But there are also lots of small moons all scattered through here. And a small telescope will show you the rings in the largest 10, get this, of 249 moons! Exclamation point. The reason is very simple. We think that something came in here, crashed into another object or two, forming the rings. This is mostly dirty water ice. And this is what it looked like 2 years ago. Finally, the rings are starting to open, and give it another 5 years and it'll knock your socks off. Absolutely beautiful world. Or in science fiction, it's called the tourist trap of the galaxy. Okay, the planet Uranus was the first planet discovered with a telescope. It will be at opposition to the sun on November 25th of this year. You need a telescope to see it. I mean, if you got really good eyes and a really dark sky, you should be able to see the planet, just a faint little kind of bluish star of 5th magnitude. The telescope shows more detail, but you need to see the disk. Its moons are usually a little too faint against city skies. Now, this is cheating over here. This is a composite off of the Voyager spacecraft, but when you put it together, there are some of its larger moons, and there's an activity in the planet's atmosphere, and then again, this incredible ring. And that was discovered. That by itself, Mary, you'd be able to put together a talk on rings and things, because with planets, as you know, they move around the sky, and occasionally a planet will go right across or occult, block out a star. So way back in 1977, NASA had a flying aircraft, which was a flying observatory. And they had a 36-inch telescope, if I remember correctly. And they were watching to see the star go behind Uranus. This would give us information about the density of the atmosphere. It would tell us of maybe even a composition, stuff like this, that because the Voyager spacecraft was being built in 1977. Well, just before the planet blocked it off, suddenly the star blinked on, off 7 times. Then went behind the planet, and sure enough, on the other side, blink on, blink off, blink on, blink off. And there was a tape that was made of this, and they said that, my gosh, you know, it's got to have rings. There's no other object there that can do this. And they said, yes, well, great. And in the background, somebody's saying, oh, what do you know? Another PhD in the world. But it was a discovery we did not at all expect. Now, you need a telescope, really, to see the blue disk. The moons are usually too faint against city skies. To be honest with you, I've seen Uranus a number of times. I have never seen any of its moons, even the larger ones. So we can show it to you, but you have to fill in with the blank with your imagination. Okay, and from all of us here at Amateur Astronomers Incorporated, a happy new year to all of you of the good earth. It's Apollo 8. Christmas Eve around the moon. Imagine that. 3 guys in the camp looking back at the earth. And this is what they saw. This is Bill Anders' photograph. He had a Hasselblad. I think he had a standard Kodacolor, which I think you could still get if you look around or you go into an antique shop somewhere. And this is the moon. Look at this. The dead earth here. The live earth over here. This could have been us if certain things hadn't happened. The formation of the moon apparently stabilized our atmosphere and particularly stabilized our orbit. The moon itself has been battered, you've seen when you looked at the pictures earlier. We are lucky we live here. A whole bunch of little primates running around, looking at the sky and wondering where they came from and where are they going. And you and I are all part of that adventure. And good evening.